morning and welcome to day 2 of distance learning. So that means if you're in my A3 or A4 classes, you should be watching this video on Wednesday, April 1st. And if you are in my B1 or B3 class, then you are watching this video on Thursday, April 2nd. So for today's review, we're going to be talking about our unit on solving inequalities. But before we dive into that, I have some feedback on your quizzes from our last class. So a couple of things to be aware of. I'm still having students use nicknames instead of their real names for the quizzes. Now don't forget, I'm not watching this live in person, so it's hard for me to go through and find your name using nicknames. So please use your first name. If you know there's another student with your first name, use your first and last name, or first name and your initial of your last name. Something so that I know it's you. It will make my life a lot easier. The second thing, I can see how long it's taking you to do each question. So I'm not giving you many questions. The last one had 13 questions on it. 10 were solving equations and the last 3 were the daily 3, like how we usually end our class. And if it's taking you 3 seconds to solve a multi-step equation, then I'm a little bit concerned. So you should be using a separate sheet of paper alongside while you're working on the quizzes, so you can show your work, you can check your work, and then you'll have time to input it. I promise you that you're not going to run out of time. You'll have plenty of time to complete each of those questions. So on today's quizzes, I really want you to take a separate sheet of paper. During this video, I would encourage you to take a few notes, and I'll point out some important things to write down. That way, when you're working on your quizzes, you're using your skills, okay? So it's not just a matter of completing the quizzes, it's a matter of actually showing your mastery on the quizzes. So to start off with solving inequalities, we're going to do a very quick refresher. I know we've done this in class, but the 4 inequality signs, and again, those notes taking, this might be a good thing to write down on a separate sheet of paper. That way, when you're going to do your quizzes, you have them, would be your 4 main inequality symbols. If you need to hit pause on this video to finish writing things down, you can certainly do that. So the first symbol that we've talked about this year was greater than. Right here. We have greater than or equal to. That's that little line underneath it. We have less than, and we have less than or equal to. And what that equal to part means is, for example, 4 is not less than 4. However, 4 is less than or equal to 4. So this allows us to see which numbers are actually included in our solution. Another thing that we've talked about with these symbols is when we do graph their solutions on a number line, we have to determine whether we're using an open or closed point or whether we're shading to the left or to the right of that number. So a very quick thing, whenever you have greater than or less than, not including that number that you see there, it's going to be an open circle. When you have greater than or equal to or less than or equal to, that's when we're going to have a closed point at that number. The second thing we need to remember is which way to shade. If your variable ends up on the left side, we can kind of use our symbol. If we look at our greater than symbols, they're both pointing to the right. So whenever we have greater than or equal to, and your variable's on the left side of your solution, then you have to shade to the right. That's where the numbers are bigger than on the right side. That's where the numbers are bigger than the previous number. And if you have less than or equal to, that's when you'll be shading to the left. Okay? So that was a very quick refresh of all of our 4 inequality symbols. We're going to look at 2 examples very quickly now. I'm going to try to post this up where our joke of the week was so that we can refer back to it. There we go. And then one other thing to remember, if you have 3 is greater than -2, but you perform the inverse operation, or you perform the operation of multiplying by -2 on both sides of our equation. I'm not sure why I'm using the x, right? If we're multiplying both sides by -2, then 3 times -2 would give you -6, and 2 times -2 would give you actually a +4. If I brought down that greater than symbol, I now notice that -6 is not greater than 4. That one rule that we have to follow whenever we're solving inequalities is that whenever we multiply or divide both sides of an inequality by a negative number, we have to reverse that inequality symbol to make that still true, because -6 is actually less than 4. So let's take a look at these two examples, and remember, we're treating them like they are equations using our inverse operations, combining like terms. The one rule we have to look for is whether or not we need to reverse our inequality symbol. So if I'm looking here at example number 1, I have 3x minus 2 is greater than 10. It might be a good idea to write this example down with me. So I still am going to separate my inequality into two sides, and we're going to look for our inverse operations. If our variable is right here next to this 3, then I want to undo minus 2, right? So I'm going to add 2 to both sides of my inequality. These will cancel out because they're inverse operations. I'm going to bring down my 3x, my 12, and then this symbol is still greater than. We haven't multiplied or divided by a negative. Our last step in solving this inequality is to take care of this invisible operation, which is multiplication. The inverse operation would be to divide by 3. I'm going to divide each side of my inequality by 3. 3 divided by 3 is 1, which leaves us with an x. We bring down 12 divided by 3, which is 4, and our symbol is still greater than. So we now know the solution to this inequality is x is greater than 4. So when you think about that, 4 isn't greater than 4, but there are a lot of other numbers that are. 5's bigger than 4, 10's bigger than 4, a million's bigger than 4. So to represent this on a number line, we like to put 0 on there so we can tell where we are. We know that 4 is a positive number, so we're going to end up down here at 4. And back to here, if our symbol was greater than does not get filled in. So we are going to have an open circle or open point right at our number 4. And since our numbers are greater than, that's where our solutions are, we're going to be shading all the numbers to the right of 4. So that's where 5 is, where 10 is, where 1 million is. So we are going to represent our solution on a number line. A very quick second example, turn this. We have -2x minus 4, and this time this symbol is less than or equal to 6, which means I can again start solving, looking for inverse operations. In this case, if this is minus 4, I'll be adding 4 to both sides, which leaves us with a 10. These cancel out. -4 plus 4 is 0. And I'm bringing down, don't forget this symbol, a -2x. And again, I haven't multiplied or divided by a negative, so my inequality symbol is still less than or equal to. Our final step here is going to be taking care of that coefficient of x. If that's multiplication, again, the inverse operation would be to divide. But this time, we're dividing by a -2. -2 divided by -2 would be a +1, which leaves us with an x. 10 divided by -2 would bring down a -5. But don't forget, whenever you multiply or divide an inequality by a negative number, in order to keep that inequality true, we have to reverse that symbol. If this symbol is less than or equal to, in order to keep this inequality true, that symbol now has to read as greater than or equal to. And so our solution, for example 2, is x is greater than or equal to -5. And once again, we'll graph that solution on a number line. We know 0 belongs at our number line. In fact, we're going to scoot this over. We know that 0 belongs at our number line, and this time -5 exists on the left side of 0. So -5 will be somewhere down here. And because x is greater than or equal to -5, -5 is included in that solution. So since it's greater than or equal to, it's going to be a closed circle. So we're going to put a closed point at -5. And again, it's greater than, so all the numbers greater than -5, for example, 0 is bigger than -5, 1's bigger than -5, 10's bigger than -5, we're going to be shading our number line to the right. So this was your very quick refresh on solving inequalities. If you didn't have a chance to write those down while I did, I'd go back and pause the video. That way you have 2 examples on a separate sheet of paper. And when you're going through your quizzes for the day, you can refer back to these questions. And I would definitely write down our little cheat sheet here. So remember, treat inequalities just like you would an equation, except for that one time you have to worry about your inequality symbol whenever you multiply or divide by a negative number. Okay? So I will see you all again. A day, I'll submit another video for Friday, April 3rd. And then my B day, you'll be watching that video on Monday, let's see, 3rd, 4th, 5th, April 6th. All right? So enjoy yourselves, guys. I'll see you soon.